We now determine the current that flows through a 3.25 farad capacitor, and the voltage that is applied to this capacitor is given by this expression 5t minus 4 over t squared plus 16. And we have to determine the current at t equal to 2 seconds using this equation. We are giving this equation for current, that is I equals c times dv over dt. So since this expression involves dv over dt, let's find the derivative of v with respect to time. So I'm going to find the derivative of v with respect to time, which I write down as dv over dt. And we have to find the derivative of this expression. This is basically a rational expression. Here we can apply the quotient rule. So when we apply the quotient rule, we consider the denominator expression that we multiply with the derivative of the numerator expression, that is d by dt of 5t minus 4. Then we put minus. Now we consider the numerator expression, multiply with the derivative of the denominator expression, that is d by dt of the denominator expression is t squared plus 16, and this should be all over the square of the denominator expression, that is t squared plus 16 quantity squared. So let's evaluate this. So we have dv over dt, and this equals t squared plus 16 times the derivative of this expression. That is, we have to find the derivative of 5t, which is 5, and derivative of this constant is 0. So it's basically 5 minus, I put this expression 5t minus 4, and then multiply with the derivative of the expression t squared plus 16. The derivative of this expression is, that is, you have to find the derivative of t squared. When you use the power rule, it is 2t, and derivative of 16, which is a constant, is 0. So I simply put 2t, and then this should be all over t squared plus 16 quantity squared. So let's continue to simplify. We have to do the distribution, that is 5 times of t square is 5t square plus 16 times 5 is 80, and we have a minus here. 2t times 5t, this is 10t square, and since we have a minus here, we should consider that negative 4 times 2 is negative 80. However, since we have a minus here, it will become positive 80, and this should be all over t square plus 16 quantity square. Now it looks like we could still simplify the numerator. We have like term 5t square and a negative 5t square. So when we add these two together, we get negative 5t square. Let me put the t term first. That is, next I put 80, and finally we have this constant plus 80. This should be all over t square plus 16 quantity square. So basically, this is the expression for dv over dt, and so we can find the current, that is multiplied I equals c times dv by dt. So this means we can determine the equation for I equals c times dv over dt, and so this equals, let's put the value of c, which is given as 3.25 farad. So I plug in 3 c equals 3.25 times dv by dt. This is negative 5t square plus 80 plus 80 all over t squared plus 16 quantity squared, and close this in a square bracket. We have to determine the current at t equals 2 seconds. So we can plug in t equal to 2 into this expression. Therefore, the current when t equals 2 seconds, and this equals, we have 3.25. I plug in t equal to 2 here, that is negative 5 times of 2 square plus 8 times of 2 plus 80. I think this is 80t. It's 80 only. Just verify that. So this becomes 8 times of 2 plus 80, and this is all over. T is 2, so it is 2 squared plus 16 quantity square. Let's evaluate this. This is 3.25. 5 times 2 square is 4, so negative 5 times 4 is negative 20, plus 8 times 2 is 16, plus 80, and this is all over. 2 square is 4, and 4 plus 16 is 20, and 20 square is 400. So I can put 400 here. And let me plug this into the calculator and determine this value. And I get 0.6175. And I put the unit of current, that is amperes. We can write down this shortly as A. So this is the current that flows through the capacitor.